Okay, got the message again, and I got to read it this time. Tells me my memory card wasn't fast enough. Now, I've been using these memory cards in an identical camera, and it's been fast enough. And it's apparently almost fast enough, because the thing lasts for a while, but it didn't last through this whole thing. So I replaced it with the memory card that came with the camera, which is 70 megabytes per second, whereas the one I was using was 50 megabytes per second. And I'm warned now, so I think I can avoid the problem. I've got a lot of memory in this card. I'll just be sure to use this one. And if it doesn't work, I'll find a faster one. Okay, so anyhow, again, and then also then I opened the memory card thing and removed the memory card before everything had been written to. So I think I lost what I have. And it's making me cough. Okay. Okay, again, from this argument, our drift velocities are in the ratio of L1 over L2, all other things being equal. But of course, if the areas are different, the current wants to be in the ratio area 2 to area 1. It also wants to be in the ratio of L1 to L2. What's our conclusion? Well, this leads us to the conclusion, and you can work out the details, that the current is proportional to the cross-sectional area divided by the length for cylinders of a given material. So the resistance is proportional to the, well, okay, now we define resistance as whatever is proportional to the reciprocal of the current, because high resistance should mean, electrical resistance should mean that you have low current, and low electrical resistance should mean you have high current. Okay, so that makes sense, and resistance would therefore be proportional to the reciprocal of this ratio, length over cross-sectional area. Now, so resistance is proportional to length over cross-sectional area, and we express that by saying resistance is some constant number times length over cross-sectional area. That constant number, the constant number we use here is rho. That's our proportionality constant. And for this situation where we're doing the proportionality between resistance and length over cross-sectional area, we call this the resistivity. Okay, so that's resistivity. And typical resistivities are on the order of 10 to the negative 8th ohm meters. Now the units are ohm meters, so that if we multiply the ohm meters here by the meters of length, we get ohm meters squared, but then that's divided by cross-sectional area, which will be in meters squared, leaving us just ohms. So you want to be aware of that, and you want to be able to think through these units, because they can help guide your thinking about how one concept is connected to another.